Hi guys, welcome back. It's Shyam again with ShyamSideResearch.wordpress.com, and I'm back with image processing made easy with Mathematica 11.1. Actually, now let's change that. Point one, part two. So um, last time, if you haven't watched part one, I strongly encourage you to go to the link below. Part one is there, but in part one, we looked over some image processing tools in Mathematica that could be done with other things like Instagram, Photoshop, Snapchat, right? Things like filters and things that are fun to play with and fun to do to fix pictures or improve them. In this part two, we're going to look at more data and a more useful technical version of real image processing. So let's start with what is image processing. Image processing is the analysis of the statistical properties of an image. So say we have an image right here. My favorite place in the world, besides Paris, is London. So here's a picture of Big Ben from Westminster Bridge. And of this picture, there's a lot of data we can get out of it, right? Obviously, in the world of data analysis, this picture and image processing, this picture is going to be a picture of some data or like cells, breast cancer cells, a picture of, say, really anything, a flower, anything that you want to analyze analytically. You can take a picture of it and analyze it on Mathematica. So, first things first, let's make what every elementary school teacher always teaches first, a bar chart. So what we can do is we can make a bar chart with when I run this. The bar chart is it's running. What we're doing here is we're running image measurements, which essentially returns like the mean color values for each of the colors, right? So if we run image measurements on this picture of a flower, right, we see that the mean R is 0.42, the mean G is 0.55, the mean blue is 0.13, and we see that green as a dominant color in the picture is going to be higher, 0.55, while there is some red at 0.42, very little blue. So RGB values right there. Then you can do a lot with image measurements, including pixel intensity and global image entropy. A lot more here. If you go to details and options, you can see all of it here. But for here, right now, we're just taking the minimum of each RGB, and then we're taking the mean RGB, and then we're taking the max RGB for the picture, right? So we see that it's just nice to see how we can quantify the RGB values for each pixel in an image. We can also do this. We can have an image histogram, which if we pull up the um, documentation about that, image histogram plots a histogram of the pixel levels for each channel and image. Right. So here we can see for each of the channels in an image, in this image, right, really brightly colored drawing of a kid's drawing, we can see the different the pixel values in this image. So purple, we got some cyan, we got some green, we got some yellow, and definitely some gray out in clouds. Here we see the same thing, right? So here it's only RGB pixels, right? Before it was a bit different. Here it's only RGB pixels, and for each of the channels in this image, we see how much R, how much G, how much blue, B, red, green, blue, and this is really nice just to so what we're doing here really is taking the mean of all of these values, right? So this is the middle, this is the minimum, right? And this is the maximum, right? So you can see the maximum is high. Um, Next, what else can we do with Mathematica? We can, of course, we did this in the last part, image assemble. And we can run an image adjust, right? So what an image adjust does, it adjusts the levels in image, right? So it adjusts the pixel values to scale them from 1 to 0, right? So pixel values aren't always going to be 1 to 0, right? As you can see here, this minimum is at 0.2 and this maximum is at 0.7 for the blue value. But what image adjust does is it it puts all the pixel values, it scales them from 1 to 0. So this is going to be 1 now, and this is going to be 0 now, so that when we look at the picture, it looks much clearer, right? So if we look, just to show what I'm saying right here, if we take this image, right? So this image is a better image, and if we run this on it, so let's call this image 1, right? And then we run that on it, right? So just to show you what I'm talking about here, right? So now the minimum is 0, maximum is 1, right? It's the same picture, but before it was 0.2 to 0.7, now it's 0 to 1. Okay, so that's exactly what image adjust is doing. So, and we can do the same thing. We can look at the histogram for that image. Look at the histogram for this adjusted image, and we can see that now it goes from 0 to 1. Before it did not. So before it went from 0.2 to 7, now it goes 0.2 to 7, now it goes from 0 to 1, right? So we can see that image adjust is a very nice tool to make an image look better. But in my experience, be very careful in using image adjust, as if you're working with data, it might screw off some of your pixel values a lot. And that's not good. Though it might look better, it might not be very good for your data. Let's move on. Let's move on to more image processing. This is a um, very useful tool that I use a lot in my research. I will be posting a case study about this later, and I will go more into this later. But for now, let's just see how it works, right? So I have an image of a bunch of cells, right? And this is going to look like a lot of code, but I will break it down for you lightly right now. I'll skim over it. Later, I will go farther into select components, because selecting components, I will post a case study about that, and I'll really go into how that works. So essentially what we're doing here is we're selecting components of this picture that follow this criterion, right? That have a hole that is of this area, right? It's a lot to take in right now, but don't worry, I will get to it later. So essentially selecting these components and putting them as cells, right? So it's getting the pixel values, not the pixel values, the position of these components in the image and labeling them cells, right? A list of these positions and labeling them cells. And then what we're doing is we're going to put circles, right, around each of these cells, right? So we're going to take the radius of each of these components, and then we're going to put a circle around them, around each of the images. It's a lot to take in. Let me just run it and see how it goes. Yeah, there we go. So essentially, what we're doing here is we're looking and finding the holes in each of these cells, and we will circle all the cells with holes. And works pretty well. It's a lot. I use it a lot for when I don't want to count by hand, and I just use Mathematica to count for me, especially when I have a lot of data, like thousands of pictures. It's really nice to just have Mathematica count the cells for me, and that's super nice. Um, let's go on to some more things that we can do. Let's see this, and if you thought that last section was a lot of code, now wait for this. This is a whole bunch of code, and it works with alpha channels and skeletons, which we won't go into right now. But if we run it, we'll see. It's going to take a second because we're running a dilation, a skeleton transform. But we see that we just got rid of everything around the leaf, right? So essentially what we're doing is we're detecting the edges of this leaf, and then we're transforming the image using a filling transform, a skeleton transform, an inverse distance transform, and then we're deleting everything else around it. And then we're just setting the alpha channel, and there we go, right? We have just a leaf, and this is very useful for when you have to crop around something, because I know my parents in their heyday, they used to use paint just to crop around an image, and now with Mathematica you can do just a couple lines of code, and it's a lot easier and it's a lot more accurate. And I know I hated going through a picture, right, with my erase paintbrush and going through in there and erasing everything. Now I can do it really fast with Mathematica. Um, you can even find places, right, on Mathematica. So let's take a place. What's my favorite place in the world? I said it just 2 minutes ago. London. It's actually not my favorite place in the world, but I can get an image, right? We can do geographics, right? Which is a very nice tool. I might do a video on it later. Geographics is a nice tool to use when you're playing with some geography, and we can make it an image. And let's make it a place. Let's do all. Um, we can do. There we go. So if you hit Control and Enter, it turns into almost a Wolfram Alpha mode, and then we can type in London, and then we'll get in a city, the city of London, hopefully. And essentially, what we're going to do here is we're going to focus in on the city of London on a range of zero point 0.4 miles around the city of London, around the coordinates. Let's try that again. London, UK. Yeah, so essentially, yeah, there we go. So we got the city of London, and as an entity, I might go into that later in a later video as well. And essentially, we're going to go in a range of zero point 0.4 miles around this and create an image of the map of London. So yeah, I actually suppressed that output. So what we're going to do next is um, let me just give me a second here. There we go. So I am going to use that image as a background, and then this should run. Ball so hard. Ball so hard. There we go. So this actually does not look so good, but what we did here was we made a picture around the city of London. And we have no labels on a street map, right? So this is nice for just creating a map. What we can also do though, right? So give me 1 second. So let me recombobulate myself. Is that a word? I don't know if that's a word. So what we did here was we created a box of zero point 0.4 by zero point 0.4 in the city of London with the coordinates of London, and we got rid of all the street labels using street map no labels. And now what we're going to do is really cool. Again, we're using the dilation tool, so you should really get into that if you want. The dilation tool, if you want to run the F1 on that, go for it. I'm not going to go into it right now because this what's going to happen right now is going to be really, really cool. So we're using this picture of London, and we're going to get, if this runs, okay. Yes, forgot to change this. There we go. And there we go, right? So we can trace out lines. We have drawn lines in the city of London, right? According to the street paths. That's amazing. That Mathematica Image Processing can go into an image, find the streets, and draw lines in them. That is mind blowing to me. We can even do the traveling salesman problem using Mathematica's find shortest path algorithm, and that finds the shortest path between 2 points on an image and you on these lines, and it's really really fun for geographical image processing, drawing these lines using a street map, and then using find shortest path to find the shortest path between 2 points. It's really cool, really fun. So we can also use some computer vision, right? Some AI in image processing. And I don't know if you guys know who these people are, but this is Gus Grissom. This is some astronauts, a picture of some astronauts, probably taken in the 1960s, 1950s. And what we can do is we can, using the FindFace algorithm of Mathematica, which is an AI algorithm trained on like thousands of faces. Using that, we can draw boxes around, we can identify and draw boxes around each of these faces. There we go. So that's really fun. FindFace's algorithm right there. We can recognize text. The Mathematica can also do that. Taking an image, it's an image. We're recognizing text using Mathematica's AI. It's really cool how it works, and it's really fun. There we go. And we can also identify images, which is really cool. We can, there we go. What is this? I'm not sure if anyone can tell me. This image is of Earth. Mathematica can even recognize an image. So this really shows off the built-in AI capabilities of Mathematica in the image world, right? So text recognition, um, facial recognition, and of course image recognition. Um, and really, that it's really insane. It's really amazing what types of things we can do with Mathematica, right? What types of image things we can do with Mathematica. This is just a cherry on top, right? There's so much we can do, and there's so much we can play around and do. So I encourage you all to go to Mathematica right now. Hit that F1 button because F1 shows you what everything does, right? That's one of the things I love about Mathematica. If I have no clue what something does, F1, and I instantly know what's happening. So really, there's a lot of stuff we can do in Mathematica. Play around with the AI, play around with the image processing. I love image processing. Use this algorithm and really enjoy what Mathematica does for you. It gives you an easy way to do a lot. Thanks. This is Shyam signing off.